Okay, greetings to everyone. I greet everyone. This video, we are going to talk about an important part in physics, talking about the resolution of forces. Before we go to the topic details, I am your online assignment tutor. You can kindly subscribe to my YouTube channel, and you can share the video to every physics students in secondary school. So today we want to talk about the resolution of forces. Before we go into the resolution of forces, I want us to talk about what is a force. What is a force? Now, basically, force is actually equals to mass times acceleration. That is a force. It's because of mass times what acceleration. The mass, of course, is in what kilogram. The acceleration is meter per second square. So meter per second square. So in reality, force is an impetus that causes the change in motion of an object. What did I say? I say force is an impetus that causes the change in motion of an object, or it causes the shift of position of an object from one point to another. So is actually causes motion. Force causes motion. So we are going to look at resolution of forces. Basically, what we call resolution is basically is just putting force into its respective component. When you plot your graph, of course, this is actually positive y-axis. This is your what? Negative y-axis. This place is your what? Positive x-axis. This place is what? This is positive x-axis. This is what? Your negative x-axis. So now let's say that a force is acting at this point here. Let's say there's a mass loaded. Let's say there's a mass loaded at this point here, and different forces are acting on it. Different forces are acting on it. For we to find the total force, we have to resolve each of these forces into their respective y-axis and x-axis, y-axis and x-axis. In the process of doing that, we call that resolution of what? Of forces. That's what we call it. We call it what? Resolution of forces. So if, let's say, we have a force acting, if this is an object, let's say we have a force acting on this object. Let's say the force is 20 Newton acting on this object at 30 degrees to the horizontal. Let's say force acting on this anything. A force acting on the object at 30 degrees to the horizontal, and we are asked to find the component forces. What do we mean by component force? What we mean by that is that we're talking about, we find the vertical component of this force, which is actually the positive y-axis, and we find the horizontal component, which is the positive x-axis. That's what we are looking for. So putting the forces into the vertical and the horizontal is what we call the resolution of the forces. One thing you have to keep in mind is this: to resolve this force into the horizontal component, you need to take note of a topic in mathematics that talk about a topic in mathematics where you have your right angle triangle. This is your what? Hypotenuse. This is your what? Adjacent. And this is your what? This is the opposite. Let's call it O. So if we were to find the any of the sides here, we use this language, this what we call, we use so Katua. So in doing this, before we can resolve this into vertical or to horizontal or vertical component, we need to complete the triangle such that this place is the hypotenuse. This place here is the same as this place. This vertical place is the same as this place. Then this place is actually the horizontal. So we are looking for the first component along this side. So we call it what? S Newton. Let's call it S Newton. That is the first thing we are looking for. And when we look at S Newton, it's actually at the adjacent, and this is the what? Hypotenuse. That means that we are going to make use of what? Cos K. That is cos 30. So at the end of the day, our cos 30 will be equals to x over 20. Very correct. That is x over what? Over 20. So if therefore x will now be equals to, when you cross multiply, it will now be equals to 20 cos 30 degrees. 20 cos what? 30 degrees. Let us clean this place so that we can write it well. So you have what? S will now be equals to what? 20 cos 30 degrees. Because this is what? This is the horizontal component. This is what? The what? Horizontal. Let's call it horizontal component. Let's call it HC, horizontal component. Now, how do we find the vertical component? So, if you look at what we have done at the time we draw that diagram, we have something like this. Because this is 30 degrees, this is your 20. We draw a complete triangle. So this side is the 20. So we are looking for this side, which is actually the same as this side. So this is opposite over what? Hypotenuse. That is sine. So our vertical component, which is y, will now be equals to 20 sine 30 degrees. So the other one we find was 20 cos 30 degrees. So if we are not going to write it properly, so we have s is equal to what? 20 cos 30, which is actually equals to, if you check up your cos 30, it will give you what? 20 root 3 over 2. I know some of you might be wondering how I get root 3 over 2. Don't worry, one of these days I'm going to show you how we can solve some special angle cos 30 cos 60, giving us without the use of calculator, but putting our answer in short form. So for now, but let us just follow this move now. So we have 2 year 1, 2 year 10. So the horizontal component of the force is what? 10 root 3 Newton. 10 root 3 Newton. This is 10. So let's check the vertical component, which is y. That is what? 20 sine 30. Of course, sine 30 is half, so that will go also 20 times 1 over 2. That is actually 10 Newton. So the vertical component is 10 Newton, while the horizontal component is 10 root 3 Newton. So basically, that is a fundamental principle of the resolution of forces. Very useful resolution of forces. Then we have numbers of forces acting at the same plane. That is what we call the coplanar forces. Coplanar forces. What are coplanar forces? These are forces acting on the same plane. That is, the force is acting at a point. Coplanar forces. So forces acting on the same plane. Coplanar forces acting on the same plane. Acting on the same plane. So what are we going to do? Why is it relevant to us? There are some times we may be asked to find the resultant force of all the forces acting on the same plane. That is a coplanar forces. Combination of different forces acting at a particular angle. So for example, if you have a point here where you have different force, let's say 60 degrees, you have another one, you have 120 degrees. Let's say this force here is 15 Newton and this one here is 20 Newton. Then I say find the resultant force. Now you have to find the resultant force. You are looking for the resultant force. Now this along this side is what? 60 degrees. Along this side is what? 120 degrees. It's not difficult to find. What we just need to do here is to find before I solve this problem, let me quickly explain to us what we know are what we call resultant forces. What is a resultant force? A resultant force is a single force that tends to bring two or more body into equilibrium. The resultant force is a single force that tends to bring two or more forces into equilibrium, and it's always equal and in opposite to the equilibrant. The equilibrant is equals to the resultant force. In fact, the equilibrant and the resultant force are actually the same. So that is why we have the same definition. It's just that they act in opposite direction. Now, take for example, you have this force. Well, for this 12 Newton and this 5 Newton. So the resultant force will be the one coming from the origin. So this is the resultant force. The equilibrant is actually opposite in direction. This is the equilibrant. Is in opposite direction to the resultant force. So how you have this situation, we are going to make use of our Pythagoras theorem that say opposite square plus adjacent square is equals to hypotenuse square, because the resultant force is at the hypotenuse. So that is what we'll make use of to find the resultant force. So the resultant force formula for a system of two forces is equals to R equals to F1 square plus F2 square root. So this is the formula for finding resultant force. Resultant force is equal to F1 square plus F2 square. And of course, it will be in what? Newton. So that is formula for finding resultant force. So if we have a situation like the one I drew the other time. When you have if when you have this type of force acting, you have 12 here Newton, you have 5 Newton here. You are now to find the resultant force. So find the resultant force, just need to draw uh, a force coming from the origin in between the two. So the formula for the resultant force will now be R equal to square root of 12 square plus 5 square. Of course, when you use your calculator, 12 square for 5 square will give you 169. So therefore R equals to 13 Newton. So the resultant force is actually 13 Newton. That force is what? 13 Newton. So in the next class, we are going to continue to get more calculation on our resolution of forces. In the next class, we'll talk about equilibrium of forces. We'll talk about resolving Coplanar forces and finding their resultant, and also we are going to look at the meaning of dynamic equilibrium and also static equilibrium. Then we solve some questions. Then we look at other possibility question that you can come across in your exam and in your interview, wherever. So before we close for today's lecture, I want you to subscribe to this YouTube channel. Share this video, like it, and the reason for this is for you to be aware that anytime I drop new video, you will be the first person to get the notification. So that is the reason why. So I want you to subscribe and share the video to every young person who is in a science class to learn, because the purpose of this your channel is for us to learn sciences, maths, physics, chemistry, because I'm still coming to chemistry also. So have a wonderful day. Bye bye.